Hello everyone, I'm Sabrina. In this video, I will show you how to use QGIS to obtain some data. But first thing first, we will go for the catchment area boundaries. But before that, let us go to USGS in order to obtain the DEM file. Add the coordinate of the place that we want. In this video, we will use top Fruit Sdn Bhd located at Johor Bahru. Click the dataset to get the result. Choose the digital elevation and then SRTM and then the second global and then choose the result. Now you can download the DEM file. Then add the DEM file in the QGIS and you can open the street map. Now you have to transfer the geographic coordinate system to projected coordinate system. So you go to the raster. Okay, and then the input is DEM and the target area is Johor grid. So you can run. Make sure to change the coordinate at the reference system. So now, both of data frame and DEM are in a projected coordinate system, which is Johor grid. Now we want to correct the DEM by filling the sinks. So we choose fill sink, Wang and Liu. So we use the reprojected DEM, and then we change the value to 0.01, and then we only save the file fill DEM. After that, we can run. Make sure that the coordinate is in the Johor grid, and then we can deactivate the reprojected because now on we will use the fill DEM. Now we want to find the stream network by using the stroller order. We use the fill DEM and we save in file. Go to the stroller order properties and then change to blue color, and we choose equal interval and choose the highest value, which is 10. However, we just want to isolate the larger rivers, so we go to the raster calculator and choose the stroller order and make it more than band 5 and save it in the files. And then go to the properties to classify it, change the color, and then classify it and also the transparency to make it transparent. Now we will do the channel network and drainage basins. So it is fill DEM and we choose 5 and we only take the channel and deactivate everything else. After that, we can run. So the river network is in a shape files. And then go to the properties to change the colors interval and also change the thickness to 0.4 sets. Now we already have our river network, so now we have to find our place, which is top Fruit Sdn Bhd. So then we can compare it and we find the place. Now we have to find the coordinate of that place, so we add a layer, name it as outlet, and we save it in a file. So now we find the coordinate by open the attribute table. But first we toggle editing it. And then we open the attribute table. From the attribute table, we can find the x coordinate and also we can find the y coordinate. And after that, we can save the coordinate. Now we can do the catchment area boundaries by using the absolute area. So we enter the both of the coordinate that we gained just now and use the fill dm and then save it in a file. Now we already get the catchment area boundaries, so we put the river network up on it. Okay, and then now we have to make sure the file in a vector, so we have to change it. So we use the absolute area and then we save as a catchment boundaries. Now we already get the area catchment boundaries. So now we move on to clipping polygon. We use a catchment boundaries and also and we want to clip it with the river network. Now we want to calculate the circumference and area, so we go to a data management tool and the vector, and we reproject the layer first. So we reproject the catchment boundaries. And then open the attribute table to find the area and also the circumference. So now we want to find the NDVI value, so we open the files and we have to enter the band 4 and also the band 5. And then we open the raster calculator to do the NDVI. So we do the bracket band 5 minus band 4 divided by band 5 plus band 4. Then we take the range value to be put in the graph letter. We open the properties to change into a single band pseudopodium, and also we change the color, and we get rid of the orange color and change the value into 0, 0.3, 0.5, and the last one is infinity. Next, we will do the atmospheric correction. So we go to SCP and we enter all the data from one raster documents, and then we go to pre-processing, and then we correct the atmospheric. So that is band 1 until band 10. And after that we run and save the file. When it's done, the file will become the RT file. And this is what is loaded after atmospheric correction. Now we want to do the land use, so we open the training input and we save the file as a classifications. And after that, we can already classify it. So first is water, and then followed by cloud, build up, vegetation, and soil. And then choose all to see the graph, and also to take it as a classification. So this is how it looks like after it being classified. So based on the NGVI value that taken from 6 different dates, so this is the graph obtained. So we already finished all, and that's all from me. Thank you for watching.